Welcome back to AutoCraft Studio. In this video, we are diving deep into the hardware that makes the Arduino Uno works. Whether you are just starting out with Arduino or looking to brush up on the technical details, this video will give you a solid understanding of the key components and features of Arduino Uno. We'll be exploring the microcontroller, digital and analog input-output pins, power supply, and more. By the end of this video, you will have a clear picture of what makes this board so powerful for countless DIY and professional projects. So let's get started and take a closer look at the hardware of the Arduino Uno. Okay, now returning back to the PowerPoint to explain some points related to hardware overview of the Arduino Uno R3. First of all, we will talk deeply in the microcontroller used in Arduino. Here we are talking about the AT Mega 328P. Okay, what is a microcontroller? A microcontroller is the central processing unit, CPU, of the Arduino Uno, responsible for executing instructions, controlling peripherals, and managing data flow. Okay, as we said in the previous video, it is the brain of the board. Okay, as we can see on the board, this is the CPU. This is the microcontroller we are talking about. Okay, this microcontroller processes all the data it receives from the sensors and decides what actions to take. Based on what? Based on the instructions you have programmed. Okay, where it can controls output like what? Like turning on LEDs, spinning motors, or sending signals to other devices. It's what makes Arduino capable of interacting with the physical world. Okay, now we will talk about the features of this microcontroller. First of all, it has 16 megahertz clock speed. That means this speed determines how fast the microcontroller can execute the instructions. This is more than sufficient to perform tasks like sensor reading, motor controlling, and basic calculations. Second of all, it has a 32 kilobyte of flash memory. Okay, and this flash memory when you write and upload a sketch to the Arduino, it is stored in this flash memory. Okay, third, it has a 2 kilobytes of SRAM. SRAM stands for Static Random Access Memory. It stores variables and data while running the program. Okay, the last feature that has 1 kilobyte of EEPROM, where EEPROM stands for electrically erasable programmable read-only memory. This allows you to store data that must be preserved between power cycles. Okay, now for the power supply of this Arduino Uno board, it can be powered in three main ways. First, throughout the USB connection. This is the USB port on the Arduino Uno board. You get this USB cable. You plug in the USB port, and then all the way to your computer for programming this board, also at the same time for powering on this board. Another method for powering this board is via an external power supply through what? Through this barrel jack plug. Okay, as you can see, this is how you connect it through all the way through a 9-volt battery. Third method, you can power this board using VN pin. As you can see on the board, here is the VN pin. Okay, written VN. You connect this wire through the VN pin, okay, to an external power supply. This allows you to provide power directly to the board. This Arduino board includes an onboard voltage regulator that ensures a stable 5-volt supply. As you can see, this is the 5-volt regulator, which is essential for the power functioning of the microcontroller and other components on the board. For now, we will talk about the most important part in hardware overview of the Arduino. Okay, we are talking about the digital input-output pins. As we can see in the board, on this board, in this Arduino board, the digital input-output pins are located from pin 0 here, 1, 2, 3 till 13, till pin 13. Here are the digital output and input pins. Okay, so you ask yourself, what is a digital pin? Okay, these pins are the connections that allow the board to interact with other electronics components. Okay, so why there is an input pin and why there is an output pin? Okay, digital input, this means that it reads. What it reads? It can read signals from external components. The signal is either high or low. So this board reads the signal as high, so the external component is on, or it reads it as low, that the external component is off. In this demonstration, we will have a practical understanding about digital input pins. Okay, as we said, digital input pins are responsible for reading the state of an external component connected to Arduino. In our case, the external component connected to Arduino is this push button. This push button is connected to a 5-volt source and is connected to a digital pin number 7 that is programmed as input digital pin. Okay, what is the reason for that? To read the state of the push button, whether it's pressed or not. When we are not pressing this button, the digital input pin will read a 0-volt signal, which lead to display on this monitor a statement that says button is not pressed. Okay, whenever you press this button, the 5-volt signal will passes through the button and reaches the digital input pin, that it reads a 5-volt signal and display on the monitor the button is pressed. Now, what is a digital output pin? Okay, it's send signal, not read signal. It's a send signal. Okay, one pin is set as output. If we set one of these pins as output, it can send signal to control devices like LEDs, motors, or relays. These signals are high and low to determine whether you want to turn on the device or turn it off. However, for setting the pins as input or output, we will explain that in an upcoming video about basic programming concepts. Okay, this practical demonstration is meant to help you understand the concepts we have covered in the PowerPoint, regardless of the specific design and programming used, since we will have separate videos that dive into the details of designing and programming such circuits and projects from scratch. So here in our demonstration of controlling LED, we will understand the concept of digital output pin. Now we will power up this circuit by connecting this cable into our laptop. Okay, as you can see, the circuit is on and we are controlling the LED. What is happening right now? The microcontroller is programmed to control this LED by turning it on and off with a delay of 3 seconds. Okay, This means that the microcontroller is sending a high signal to the LED, which is a 5-volt signal, through what? Through the pin number 7, which is programmed as an output pin to what? To turn on this LED. Okay, after 3 seconds, it will turn off. How? By sending another low signal, which is a 0-volt signal, to turn off this LED. If you found this video helpful, please give it a thumbs up and don't forget to subscribe to AutoCraft Studio for more in-depth tutorials. Feel free to leave a comment if you have any questions or suggestions for future videos. Thanks for watching.